Hello Year 11, it's Miss Bailey here. In this video we're going to be going through the reversible reactions exam questions. So in this first question we are looking at cobalt chloride paper. Now we won't have used cobalt chloride paper before, we may not have even heard of cobalt chloride, but we have all the information that we need in this question. So they've told us that we have anhydrous, so we're familiar with that from looking at copper sulfate, so this means without water. And we can see from this symbol that it is a reversible reaction, and we can see that there's a colour difference between our anhydrous and our hydrated cobalt chloride, just like there was with the copper sulfate example that we looked at. With the copper sulfate, our anhydrous was white and our hydrated was blue, but in this example our cobalt chloride is blue when it's anhydrous, but when it is hydrated it's pink. So in this part A we have to choose one of these words to complete the sentence. So the symbol with a forwards arrow, half arrow, and a backwards half arrow, that tells us our reaction is reversible, as we discussed up there. So that means it can go in one direction, but also it can go back in the other direction. Describe the colour change when water is added to the cobalt chloride paper. Now it's important to note that they've said change, so we want to know what it started with as well as what it then ends up as. So we can't just write one colour, we need to say what it's gone from and to. So looking at this equation, we can see that when we add water to our anhydrous cobalt chloride, we end up with our pink compound. So it goes from blue to pink. So moving on to part C, suggest why the jar containing the unused cobalt chloride papers must be kept closed. So if our cobalt chloride paper is used to test for water, one of the key things we have in air is water vapour. That's one of our molecules. So if the container isn't kept closed, we're going to be exposing it to water, and therefore it become hydrated and pink, and therefore we wouldn't be able to use it to test for water if it's already been exposed to the water vapour that is in the air. So it needs to be kept closed to keep any moisture out. Okay, so this next question is about hand warmers and how they are used in chemical reactions. So we have a table looking at reaction A, B and C, and we are measuring the final temperature and then calculating its change in temperature. So we've just got to fill in our table for row B. So we're going from 17 and we're looking for a change in the positive direction and for it to go up by 5. So we want to do 17 plus 5, which gives us 22 degrees Celsius. The next question is what name is given to the reactions that heat the surroundings? So we're releasing energy to the surroundings, and that is our exothermic reaction. So remember, X, like in exit, is a good way to remember that our energy is exiting from that substance. Which reaction, A, B or C, would be best to use in a hand warmer? So here lots of us were correctly saying C, but our reason for this wasn't always meeting what the mark scheme would be after. So lots of us were saying it was because it was exothermic and therefore would be best, but actually if we look, all of them are exothermic. But the reason why we chose C, and we were correct to choose C because our intuition told us it should be C, and it's because it's got the largest change in temperature. Okay, so part C we are adding water to anhydrous copper sulfate. So similar to that reaction from question 1, but instead of cobalt chloride, we are using copper sulfate. So the measurements showed that this reaction could be used for a hand warmer. So when we are wanting a hand warmer, we are wanting it to be warm, and therefore the temperature must have increased in this reaction. So anhydrous copper sulfate is white. What colour is seen after water has been added? We mostly all got this, which is blue. So those nice blue copper sulfate crystals you've probably made before last year. This question we've had before about the symbol, that's reversible. Remember, it's got part of a forwards and part of a backwards, showing they both happen at the same time. A student heated the tube containing hydrated copper sulfate. Name the solid substance produced. So by heating it, we then do the reverse of that reaction. We remove the water, and so we end up with the anhydrous copper sulfate. So this next question, we are looking at the ammonium chloride. So we've got decomposition when we've heated it. So what this shows us is that we need heat in order for that ammonium chloride to decompose. Whereas at the cooler part of the tube, that's where we then get that reversible reaction. And so if we're requiring a high temperature for the decomposition, we need to select the decomposition one to have a high temperature. So decomposition going from that one product to more than one product. So reaction 1 is taking place at the high temperature, whereas reaction 2, we are combining those products to reform the ammonium chloride. And so that's taking place at a low temperature at the cooler part of the test tube. Part 2, I think we got a bit confused by this one because we thought about the heat and we thought about combustion and oxidation being things where we would normally heat substances in oxygen for a combustion reaction or combining oxygen in an oxidation reaction. But actually, it is talking about a reversible reaction because it's exactly the same reaction. One's going in one direction and one's going in the opposite direction. So we have said that this is a thermal decomposition reaction, but if we're talking about both of those reactions, then we need to be thinking about both stages combined, and the only word to describe both of them together is reversible. Suggest a reason for the mineral rule at the top of the test tube. So this is in order to stop any of that ammonium chloride product escaping. Okay, and then in this question we're looking at our experiment where we've added water to the ammonium chloride and measuring the temperature both before and after. And so what we can see here is that our temperature has decreased after adding water, and therefore we're being asked to look at which of these words would best describe this process. So because the temperature has decreased, that tells us we've taken in energy, and therefore it must be the endothermic reaction, because remember, N is almost like in, so taking in that energy. So in this next question, we're sticking with ammonium chloride and its decomposition into ammonia and hydrogen chloride. And so for that first question, apart from the gases in the atmosphere, which two gases would normally be at X? So at X, we're looking at those gases that have been produced from the decomposition of ammonium chloride. What gaseous products does the ammonium chloride break down into? So that's going to be ammonia and hydrogen chloride. And name the white solid that's formed at Y. So that's where our gases recombine in the cooler area and will reform the ammonium chloride on the inverted glass filter funnel. So ammonium chloride. Why was the demonstration carried out in a fume cupboard? The reason why ammonia and hydrogen chloride are particularly dangerous is because they are both toxic fumes. So by carrying it out in the fume cupboard, those toxic fumes can be kept away from anyone who's carrying out these experiments. So we've then got 4 spaces in this sentence to be completing. So chemical formula of ammonia is NH3. This shows there is one atom of, so N doesn't have any numbers near it and therefore it's only one of them. And using our periodic table we can identify that that is nitrogen. And then we've got 3 atoms, so that 3 coming directly after the H. And using our periodic table we can identify H to be hydrogen. So 3 atoms of hydrogen in each. So when we have atoms that are bonded together, we call those molecules. So in one molecule of ammonia, these atoms are joined by bonds that are formed by sharing pairs of electrons. This type of bond is called, so when we share, for example sharing work, we are cooperative. So that start there, co, tells us that it's a covalent bond because it shares the outer electrons in order to bond. And remember that covalent bonds, those are between non-metals and non-metals. Both nitrogen and hydrogen are non-metals. In part B, we can then look at our subatomic particles. So 2 of them have mass and 1 has a negligible mass. 2 have charges, opposite, and 1 is neutral. So neutral is always the easiest one to start off with because the name sounds like neutral because they both start with neut. So neutron is our neutral particle that has a mass of 1. And then for our positive charge, remember that proton is positive and they both start with a P. And that then leaves electron being our negative charge, which has negligible mass. So which of these are found in the nucleus of an atom? So if we picture our atom and our nucleus, we have our electrons that are on our outer shells, and in the nucleus, this is where all of our mass is located. And so if we look at which particles have mass, our significant mass particles there is our proton and our neutron. So that nucleus there is positively charged because of the protons, but overall the atom is neutral because of the electrons that then balance it out.